All right, this is Module 3, Lesson 22. We're going to go over the problem set. And for this lesson is going to be about finding factor pairs. Factor pairs are just the numbers that you multiply together. So anytime you can multiply two numbers together, they're factors of the number that is your product. And we're going to be finding factor pairs in this lesson up to numbers up to 100. And we're going to be defining prime and composite. Well, the first one, number 1, says to record the factors of the given number as multiplication sentences. Okay, so we're going to use factors and as multiplication sentences. There's a factor, and these are two multiplication sentences here. And we're doing all the factors of 4. There's only 2 ways to make 4, and that's 1 times 4, and 2 times 2 is 4. So the factors are 1, 2, and 4. Now, it says to classify as prime or composite. Well, the definition of prime is if it only has the factors itself and 1, then it's prime. So this has more than 1 and 4, so therefore it is not prime, it is composite. Well, let's look at 6. Well, how many ways can we make 6? Well, we can have 1 times 6, that equals 6. And we can have 2 times 3 equals 6. And that's it. So we have 1. And I like to do this like this. Sometimes I like to find the factors first and then do the sentences, but you can do it either way. You have 1 and 6. Then you say, oh, 2. 2 times 3 is 6. Well, 4 won't work, or 5. So there are our factors, and it's composite. Now let's look at 7. We have 1 and 7, but nothing else times 7. Nothing else. 2 times something can't be 7. 3 times something can't be 7. So the only way to make 7 is 1 times 7. And since that's the only way, it's considered a prime number. And we can do that for all these numbers, every number we go through and we try to figure it out. Well, with all of them, every single number on here is going to have 1 and itself. So you could write down all the numbers of 1 and then the number times itself. And the numbers of 9, so we know we have 1 and 9. Now we have to think, is there any other way to make 9? 2 times something? No. 3. 3 times 3 equals is 9. No 4, no 5, so 1, 3, and 9. And it is composite because more than 1 times 9 equals 9. And 12, now it's going to get a little bit more complicated. 1 times 12, because there's going to be more than just, so far we've only had a few of them. And I'm going to hit the pause button on the video. So hang in there. Hello? Alrighty, I'm back. This is what happens when we're doing live recording. Anyway, we have 1 and 12. And I think about it, well, 2, let's see, 2 times 6 is equal to 12. Now, what about 3? 3 times 4 is equal to 12. So now I have, oops, I didn't even write this equal 9. It's equal to 12, it's equal to 12. 3 times 4 is equal to 12. So I have 3 sentences there, and I have 1, 2, 3, 4, 6, and 12. So it is composite. Then we get to 13. 1 times 13 is equal to 13. And there's no other way to do that. 2 times something, 3 times something, 4 times something. Nothing will equal 13. So 1 and 13 are the only factors, and therefore it is prime. 15. Well, I have 1 times 15 is equal to 15. Are there any other ways to make 15? Well, let's see. How about 2? No, how about 3 times 5 is equal to 15? Okay, so then our other factors are going to be 3 and 5. So it's composite. And again, if I'm going too fast, I'm going to go through the rest of these fairly quickly. You can always hit the pause button. All right, the next one is going to be 1 times 16 is equal to 16. So I have 1 and 16. Let's see, 2. 2 times 8. 8 and 8 is 16. Equal to 16. So I have 2 and 8. And then let's see, 3, 4. 4 times 4. 4 times 4 equals 16. Then I'll have 4. Okay? And I can't do 5 or 6, but it's composite. Okay? Moving along to 18. How many ways can we make 18? Well, 1 times 18 equals 18. 2 times 9 is equal to 18. 6 times 3 or 3 times 6 is equal to 18. Let's see, 4, 5, nope, it's composite, so I have 1 and 18. I have 2 and 9, and I have 3 and 6. 6 times 3 is 18. There we go. And 19, 1 times 19 equals 19. And there's only 1 and 19. No other ways to make 19, so it is prime. And we have a couple more to do here. 1 times 21 is equal to 21. And let's see, how about 3 times 7 is equal to 21? And those are the only ways. So we have 1, 21, and we have 3, and we have 7. So it's composite. And finally, 6 times 4. Let's see, 6 times 4. I already gave you two of the factors. Woohoo! But we have 1 times 24 is equal to 24. We have 2 times 12 is equal to 24. We have 3 times 8 is equal to 24. We have 6 times 4 is equal to 24. Lots of factors of 24. So we have 1 and 24. We have 2 and 12. We have 3 and 8. And we have 4 and 6. Look at that. Lots of factors for 24. It is composite. Well, let's get to the flip side of our problem set. And number 2. All right, in number 2, it says to find all the factors of the following numbers and classify each number as prime or composite. Explain your classification as prime or composite. Okay, all the factors of 25. We have 1 and 25, and we have 5 times 5 is 25. So 5 times 5 is 25, and those are the only ways to make 25. And then we have all the factor pairs for 28. We have 1 and 28. We have 2 and 14. And then we have 4 and 7. Those are the ways to make 28. And the factor pairs for 29 are 1 and 29. So 25, 25, and 28 are composite. And 29 is prime because the only factors for 29